Hey guys, today I would like to show you how to digitize different steels elements from point cloud in Revit with the CloudWorx plugin.
The first thing that you should know about Revit is that it's a software. The main purpose is to design elements from scratch. It is suitable for work with straight walls and beams when all elements are placed on corresponding levels and on relevant axes without leans and with right angles. But in real life it doesn't look like that. And when we're working with point cloud, we are trying to create a digital copy of the real environment, but the Revit doesn't work properly if all elements will be generated with a small lean and with slight deviation from X, Y, Z axis. That's why working in the Revit with point clouds, you should always find a compromise between accurate and right modeling. Generally, steel elements designed in the Revit are based on levels and axis position. So let's see which tools in the CloudWorx we could use to specify these levels and axes for our project. To determine the height of the level, you should use the Set Level by Point command. Choose it and just click on the place in the point cloud where you want to create the level. In the pop-up window, specify a name for it and choose the relevant view. To create an axis, you can use the Create Grid Line tool. With this tool, you must specify a point in the cloud that should be used to fit a patch in the surrounding area. So it should be a point on the flat surface. This patch will represent the axis for your element. As you might imagine, this method doesn't exactly determine the position of the axis because it uses the surface of the element to extract the patch. So the axis will be slightly offset from the center of the steel. This method can be used for some other application as well. But in any case, it helps us to determine the direction of the axis. Once created, you can move the axis closer to the center manually. The grid line tool works very well when you have a clean point cloud with the required elements that can be used to extract patches, but in many cases there are too many obstacles that prevent you from using it correctly. In this case, you must draw this axis manually, but before that I recommend you to rotate your point cloud if the position of the main elements different from the X and Y axis. To do this, draw two lines that will represent the current direction of the beams and the desired direction. Then click the Move Object Auto Align command. In the pop-up window, choose Rotate Point Cloud. Next, click on the center of rotation, the start point of rotation and the end point of rotation. For all these points, you could use previously created lines. After rotation, just create a section with one of the tools from the clipping toolbar. I prefer to use the Z-axis section for that. Next, draw the main axis manually and copy them at the corresponding distance. Now you can use the axis to create steel columns in the intersection. Go to the relevant flow plan and first of all, you should configure your viewing parameters. Type VR on the keyboard and you will see the viewing range windows. Specify unlimited parameters for primary range and for view depth menus. Also, don't forget to switch the level of detail to medium or fine to see all steel elements. After that, you go to the structure column, select the appropriate column from the families and click the Add Grid button. Select all axes to be used to place the steel elements and click OK. All columns will be placed at the intersection of the selected grid lines and extended to the specified level. For horizontal beams, you could use the same axis, but you should use another tool. Go to the relevant flow plan, structure menu and select the beam tool. To place multiple beams, you could use the on-grid tool, and for placing only one element, you could draw it manually. And don't forget that you should set the correct elevation level and choose the right placement order. In my case, I set elevation level on the top of the beam's element. That's why I specified justification by Z at top and stick symbol location also was top of geometry. When you don't know the right dimension of your steel or it has a lean position, you could use the Fit Steel tool, which is located on the CloudWorx Fitters toolbar. Let's have a look at what exactly steel elements are supported and how this tool works. At the moment, the CloudWorx supports the below types of steel: I-beam, wide flange, T-shape, tabular rectangular tube, channel U-shape, and angle L-shape. To fit any of these elements into the point cloud, you should click the Fit Steel button and define the settings of the fitting. Choose the type of steel that you would like to fit in the cloud. Select the catalog the CloudWorx will be using to search relevant dimensions for your steel. If you don't want to use any catalog, you could skip this step. Select the level to assign this element to it. You could select any level you want. Define levels of extension for vertical beams. Before doing that, don't forget to set these levels with the Set Level at Point tool. You should do this step only for column type elements. Enable the Align Steel mode if you want to create steel relevant to the major axis. If you will disable this mode, then your steel could have a little lean, because the software in this way try to fit the steel to the cloud as accurately as it possible. For most cases, I enable this function. After all settings are defined, you could specify 2 points for fitting the steel. The first, primary selection point, is on the part of the structure that adequately represents the structure's cross-section. That is as good and as clean as possible with respect to overall structure. The area, about 20 centimeters along the primary axis around the first primary selection point, must be free of attachments, and adjacent structures must have a distance of at least half the target structure's cross-section extent. The second point is used to define the approximate trajectory for extrusion of the cross-section, so try to put it on another end of the steel. The parts table dialog appears if use steel catalog is checked. If you think that any other element got more relevant dimension, you could just select it from the list, and on the right preview window you could see how the element will be fitted to the cloud. After placement of the steel with the enabled Align Steel mode, always check its cross-section rotation angle. It could be slightly different from the basic angle, so change it manually to 0, 90, 180 or 270 degrees, or round the angle values to any nearest whole number. Also, you could create your own catalog for the desired type of steel and use it in all your projects. It's very easy. Just go to C Program Data Leica Systems Catalog folder and you will find all files that CloudWorx uses for choosing the sizes. Let's try to create our own catalog for white flanges as an example. Go to the Steel White Flange folder, choose any file, copy and rename it. Double click on it and choose the notepad as software to open this file. In the appeared window you will see the list of all available dimensions for that type of steel and units in which these dimensions are specified. Add your own element in this order: name of the element, height, web thickness, width and flange thickness. Use a comma as a column separator and a dot as a decimal separator. Next, save the file. Run the Fit Steel tool in the CloudWorx for Revit and you will see that now your catalog is available for modeling. When you define all your main steels, you could just copy and paste them and align them to the point cloud manually. Sometimes it's faster than trying to fit each element into the cloud. Use different clipping tools for separate point clouds and use different views to align the steels. Floors and ceiling plans used to align the horizontal position of the beams. Elevation and section views used to align vertical position of the beams. After all main steels will be created, you could go to the next step and add connections to them. There are different ways how to create connections. One of the easiest tools for that is located on the native Revit Steels toolbar, which calls parametric cuts. Basically, you could use meter or saw cut flange tool to extend automatically beams to each other, but there is one more interesting tool for beam connections. It's Connect Steels tool that you could find on the CloudWorx Fitters toolbar. Click this button and choose in the appeared window any relevant type of connection. Next, follow the recommendations for selection order, which will appear in the left bottom corner of your screen. When the connection will be created, switch to the fine level of details to see it on the screen. In the edit settings of the connection, you could change sizes, the number of bolts and other parameters. You could use the connection tool also for creating base plates. Just click on the connection button, select your beam and you will see the green generate connection. Select it and change its type. In addition, you could create your own connection plate and specify the location for the bolts. For that, set the working plane in the right position with the Fit Work Plane tool. Click on it, select pick type, specify the point in the cloud which should be used for plane extraction. You will see the working plane will appear after you click the point on the flat surface on the plate in the point cloud. Now you could go to the Steel toolbar and choose the plate tool. You could draw the plate with any shape based on the point cloud. After it will be done, you could change the thickness and add bolts. As you could see, the steels created with the CloudWorx plugin could be easily usable with the standard Revit tools. Also, you could add technical holes for engineering with the contour cut tool. Left on the screen section in the point cloud where you could clearly see all holes, and just stroke them with this tool and it will create a hole in your steel or plate. And don't forget that if you can't see something information in the point cloud clearly, you could open the TruSpace in the additional window and look closely at the details on the each diagonal panoramic image. For that, click Open TruSpace and you will see in the pop-up window the closest panoramic image to the specified point. In that window we could change visible objects and switch between different types of navigation.
I hope this video was helpful for those users who are starting to work with point cloud in Revit. And I would like to remind you that all details about this and other tutorials you could find in the link in description below. So thanks for watching and see you next time.